So in this video, we're also going to use proof by contradiction to prove the statement P, which is if x is a multiple of 6, then x is a multiple of 2. So that's my statement P over here. And what I'm going to do is I'm first going to rewrite the statement P as an argument where I have if Q, then R. And again, my Q over here is basically this piece over here. So this entire piece over here is my Q. And so this is my Q. Again, Q is in fact x is a multiple of 6. That's my Q. And my R over here is going to be x is a multiple of 2 in yellow, and that's my R here. Okay, and that's my Q. Okay, now because I'm using proof by contradiction, I'm going to assume that the negation of P is true. Okay, which is negation of P is saying Q and not R. So let's assume that not P is true. And I'm making that assumption of not P actually being true. I'm claiming that Q must be true, and not R must be true. Okay, so by assuming that Q is true, and Q happens to be x is a multiple of 6. Okay, so saying that x is a multiple of 6, meaning x can be written as, so starting with this assumption that Q is actually true. Because I know this is true, let's say x equals to 6y. X is a multiple of 6, which means that x can be written as 2 times 3 times y. Okay, and this x on the left hand side can be written as x times 1. Now I also know that this piece over here, whatever this piece over here, this is definitely is a multiple of 2, which means if the right hand side is a multiple of 2, the left hand side must also be, this must also be a multiple of 2. And the left hand side is a multiple of 2, then either 1 is a multiple of 2, either 1 is a multiple of 2, or x over here is a multiple of 2. But then if I'm claiming that not R is also true, R over here is a statement that says x is a multiple of 2, not R is a statement that tells you x is not a multiple of 2, then that implies that 1 must be a multiple of 2. And to claim that 1 is a multiple of 2, well, I know already from prior knowledge that 1 is not a multiple of 2. So if I have a statement C somewhere over here from my prior knowledge, see the statement from my prior knowledge says that 1 is not a multiple of 2. And this is from my prior knowledge, this statement C. I've just, using my laws of inferencing, I have concluded, in this case, not C. From my prior knowledge, I know that C is true. C is equal to 1. But from these inferencing, I've also concluded that not C must also be 1. So what I have here is a contradiction of C and not C. This has resulted in a contradiction, and because this has resulted in a contradiction, my original assumption of not P actually being true is incorrect, which means that not P is equal to false, or P is actually true. This original statement over here must be true.